Now, let's see the phenomena of total internal reflection occurring in prisms. Refractive index of glass is 1.50 and critical angle is 42 degrees. Therefore, a light ray traveling through a glass prism will undergo total internal reflection from a face on which it is incident at an angle of incidence greater than 42 degrees. Based on this, total internal reflecting prisms have been designed. What are total reflecting prisms? A prism having an angle of 90 degree between its two refracting surfaces and the other angles each equal to 45 degrees is called a total reflecting prism. That means any prism having an angle of prism as 90 degree and base angles as 45 degrees will act as a total reflecting prism. What are these prisms used for? It is used for the following three purposes. First, to deviate a ray of light through 90 degree. Second, to deviate a ray of light through 180 degree. Third, to erect the inverted image without producing deviation in its path. Now let's see how a prism can deviate a light through 90 degrees. Now see normal, right? So now this was 90. This obviously is 45. Then what will this angle be? 45 degrees. So angle of incidence is equal to 45 degrees. Then you know that this is greater than the critical angle. So at this point, the light is not going to come out on over here. Rather, it will suffer total internal reflection. So angle of reflection also over here will be 45 degrees and it is going to fall on this surface normally. Now since it is fallen normally on this surface, it will come out undeviated over here. So here we will get the image of this point P at this place. Similarly, this ray will follow the same path, falling normally on the surface, right? Then it will go undeviated. Here it will suffer total internal reflection and then fall normally. So here will be P dash. So what are you going to observe? That this is the image. So originally the object was in this manner. When you saw the image obtained is this way. So now here the light has deviated through an angle of 90 degree, suffering total internal reflection at the surface of. Now let's see how light gets deviated through 90 degree in a prism. Now over here you can see a prism. This is having an angle of 90 degree and the other two angles are of 45 degrees. This is 45 degrees and this is 45 degrees. Let's say there is an object over here, PP dash. Now light from this object is falling normally on the prism. Whenever light falls normally on a surface, it always passes undeviated. So it will travel straight and reach the other surface. At this surface, the angle of incidence is 45 degrees. How? This is 90 degree. This obviously will be 45 and over here, this is the normal That means this angle will be 45 degrees. Now this angle of incidence is equal to 45 degrees, which is greater than the critical angle. So light will suffer total internal reflection at this, and it will get reflected at an angle of 45 degrees, and it will fall normally on the surface. When it falls normally on the surface, it is going to again pass undeviated. So the light which had traveled from the point P will be seen at this point. Similarly, light from P dash will travel in this manner, and in the same way it will get totally internal reflected over here and reach at P dash, and you will find this to be obtained in this manner. That means the object which was kept in front of the mirror in this manner finally was seen in this way. That means has deviated through an angle of 90 degree. This is this process of deviation of light through 90 degrees is made use in a periscope. Over here you can see how light is falling on this kind of a prism and it is getting totally internally reflected. Now let's see how this process is utilized in a periscope. I hope you know a periscope is a device to see things which are above the walls or the boundaries. Now here, this is a periscope which is using mirrors. Now, what happens in a periscope? This is an object. Light from the object falls on the mirror. It gets reflected, right? And then falls on the other mirror and then gets reflected and reaches the person's eye. Now, it enables the person to see this object which is not seen directly. If we use a mirror, then you already know in this the image formed is not so bright, and afterwards this mirror strip may get tarnished or spoiled. So instead of using a mirror strip, we use a prism. A prism which is going to deviate a light through 90 degrees. So just see, observe carefully how the prism is kept. This is just what you did just now. So over here the light is falling on this prism. Then from this it is getting suffering total internal reflection and is falling on the surface of the second prism. Just see how these prisms are facing each other. Then at this surface, it suffers total internal reflection and finally reaches the eye. And now you know that why we are preferring to use a prism, because 100% light will be getting reflected, image form will be very bright, and there will be no question of getting the prisms getting tarnished or spoiled up. Now let's see how a prism can deviate a light through 180 degrees. Now here what we have done is we have had the object kept at the hypotenuse of the prism. Now this is the object you can see. Now let's say light from this point Q is falling over here. You can see falling normally on the surface. Since it is falling normally, you all know it will go undeviated and reach over here. Now over here, this is the normal. And since this is 45, this is 90, what will this angle be? 45. So according to geometry, this is going to be 45 degrees. Here again, angle I is equal to 45 degrees, which is greater than the critical angle, that is greater than the greater than the 42 degrees, which is the critical angle of the glass. Now over here, this light which had come from Q will suffer total internal reflection. It will travel and it is going to reach the other surface. Now at the other surface again, you will observe that this will have an angle of incidence as 45 degrees. it will again suffer total internal reflection over here and fall normally on this surface and will be observed at this point. Now, if you wonder why is this 45, then you can very easily see that this angle was what? 45 degrees, isn't it? This is 90 already there. So what will this third angle be? 45 degrees. So since this is the normal, this angle of incidence will be 45 degrees. So similarly, light from P will also travel in the same manner and will be observed at this place. So the object PQ, which was placed like this, is now being observed in another, this way. So how has the light has shifted from this way to this way? That means suffered a deviation of 180 degrees. Where is it used? It is used in binoculars. And let's see how. You can see binoculars, and here you can see the section of the binoculars, how the prism, the light is entering, it is getting totally internally reflected, enter the other prism, and then it reaches the over here. Here is the object, and here it falls over here, gets total internal reflection, then again through another prism, and finally reaches the person's eye. And here this is showing the uh, position of the prisms in both eyepieces of a binoculars. Let's see how to form an inverted image without any deviation using a prism. This is also known as an erecting prism since it will give an erect image of an inverted object. So over here, you can see a prism which is having 90 degrees at over here. This is base angles 45 degrees, 45 degrees. And this is the object which is upside down over here. Arrow is at the bottom. Now, light from this point X will fall over here. Now, since it is not falling normally at this surface, so it is traveling from rarer to denser medium, so it is going to bend towards the normal and take this path. At this particular surface, it suffers total internal reflection and it reaches the other surface at this point. Now over here, again it is not falling normally, so it will not go straight, but it is traveling from denser to rarer medium. So again it bends away from the normal and takes this path. So the light which had originated from X is seen at this place X. Similarly, light from Y will follow an identical kind of a path and you will be able to see it over here. So children, if you see the light which originated from X at this place is observed over here, and light which was starting from the point Y is observed over here. So you have obtained an erect image of the object using this prism. Where is it used? It is used in a slide projector. Now finally you can observe these diagrams again. First diagram, this is indicating bending of rays by how much? 180 degrees. Second, it is indicating how the rays are bending by 90 degrees. And finally, you will find an erecting image. So just see how these objects, if you want to bend the rays, the prism is the same, 90, 45, 45. If you want to bend the rays by 180 degree, then the object is kept at this place, or it may be at this place, but anywhere over here. If the rays have to be bent by 90 degrees, then the object has to be kept on the refracting surfaces where this angle is 90 degree at this surface or this surface. And if it is to be used as an erecting prism, then the object has to be kept in front of this hypotenuse type of the surface. Total internal reflection in other prisms. A prism of each angle 60° can be used to deviate a light through 60° by total internal reflection. A 30°, 90°, 60° prism. That means a prism having an angle of 90, 30, 60 can be used to deviate a light ray incident on the side opposite to the 30° refracting angle through an angle less than 60° by total internal reflection. Now let's see how total internal reflection takes place through an equilateral triangle. Now over here, this is a prism having each angle of 60 degrees, right? Now since it's identical, the object can be kept at any of its surface. So here the light is falling from P. It is falling normally on the surface. Since it is falling normally on the surface, it will go undeviated and fall on this surface. Now, children, this is 90°. This is 60 degrees. So what will this be? This will obviously be 30 degrees. This is the normal over here. Since this angle is 30, this angle will be 60. So angle of incidence is 60 degrees. And you know that this is greater than the critical angle. That means it is greater than 42 degrees. So at this point O, light will suffer total internal reflection and it will follow this path. Now, since this angle of incidence is 60°, so reflection will also be 60. And over here, this is the normal. So what is this angle going to be? This angle is going to be 30 degrees. This is 60. Here, this is obviously going to be 90. So that means the light is going to fall normally on the surface and it will emerge out undeviated. So this is how total internal reflection takes place through an equilateral triangle. Now let's see how the light deviates through a prism having an angles of 60, 30 and 90 degrees. Now see, this is a prism with an angle of 90°, 30 and 60. Now light is falling on the surface which is having angle 90 and 60°. Now this light is falling normally. So what will happen? It will go straight and it will fall at this place. Now over here this is 90, 30. What will this angle be? 60°. Sorry, this was 90, 60 and this angle will be 30°. Now, this is the normal. So, what will this angle be? Obviously, 60°. Now, this 60° is greater than the critical angle, isn't it? It is greater than the critical angle. So, at this point, our light will suffer total internal reflection. And here the angle of reflection will be 30 degrees. This angle on the other side will be how much? 30 degrees. Now, light is going to fall on this surface and since this is 30, so this total angle will be of 120 degrees. Now, this is the incident ray. You can see this is the normal. Since this total angle is 120, this is 90. So what will the value of this angle be? 30 degrees. That means now here the angle of incidence is 30°. So this is not, it is less than the critical angle. So what will happen to light at this place? It is going to refract. It will come out of the glass prism and since it's moving from denser medium to rarer medium, it is going to bend away from the normal. So this is how the light travels through a prism if it is having angles as 90, 60 and 30. Now let's see how the light, when it falls on a prism of 30, 60, 90, suffer through an angle greater than 60 degree. Now see over here, this is a right angled prism. This angle is 90 degree. Here you have 30 degrees, this angle, and this is 60 degree and this is 30 degrees. Now the light is falling normally on the surface and it will move undeviated and fall on the other surface. This is going to be the normal. Now, since this angle is 90 degree as it is falling normally, 60, obviously this will be 30 degrees. So what is this 60 degrees? That means angle of incidence is equal to 60 degree, which is greater than the critical angle. So light will undergo total internal reflection. So from here, it will get reflected and it will fall on the other surface. This angle of reflection will be 30 degree. So this is 30, this is 60, right? And this is the normal. So what is the angle of incidence over here? This is 30 degree. So now here the angle of incidence is 30 degree. So light will not suffer TIR, isn't it? What it will do, it is not going to, it will come out of the glass prism, and since it is moving from denser to rarer medium, it is going to bend away from the normal. Now refraction through the prism without total internal refraction. Now, it is not necessary that if you have a prism, as we were discussing, of 90, 30 and 60 degrees, then the light has to suffer total internal reflection. In this situation, you can see the light is falling on this surface. It is falling normally. It goes undeviated, falls over here. Now, since it went undeviated, this is 30, you can see. This is 90. What will this angle be? 60 degree. So, what is this angle of incidence? 30 degree. So, this is not greater than critical angle, not even equal to critical angle. So, what will happen? The light will undergo normal refraction phenomena at this point. And since it is moving from denser to rarer medium, it is going to bend away from the normal.